Okay, so first things first, let me do a little revision. It's just moving some of the pieces. In this case, the NIC, I will move it a bit to the bottom because we need the space. What else? I will move this layer 1 physical binary. I will move it here because we need the space. And I will also move these somewhere here. Okay, I will keep the Ethernet in the center. There you go. Okay. Now the reason why we need to move this because we're gonna add another piece, another devices. Actually, another device, one device in our network. Okay. This is what we call the Ethernet switch. Okay, Ethernet switch, and it is a device that connects to not just one or two endpoints. It can connect to many, as it can be hundreds, by the way. Some Ethernet switches has 8 ports, some has 24, 48. But the biggest, okay, enterprise level or large data center level, it can have hundreds of ports. Now, in this case, PCA and PCB are already connected. We're gonna add more devices, more endpoints in our network. So what I'm gonna do is I will add server C, and I will also add server D. Okay, now server C, what I'm gonna do is I will also assign a MAC address and an IP address. We're gonna make this simple. Instead of the complete MAC address format, I will just specify the last group, the last byte. So PCA, PCB 01 and 02. Let me correct this. It should be 02. The server C will have 03, and the server D will have 04. There. Now for the IP address, I will assign 192.168.1.3 for server C, and 192.168.1.4 for server D. What else? I'm also gonna assign an interface or switch interfaces. I will assign E1 or Ethernet 1 directly connected to PCA, Ethernet 2 directly connected to PCB, Ethernet 3 and Ethernet 4 directly connected to server C and server D. Now take note, Ethernet switch is a layer 2 device. Okay, it's a data link layer and it operates MAC addresses. Okay, take note, it operates MAC addresses, and that's what we're gonna talk about. How does Ethernet switch learns endpoints? The answer is through MAC address, and Ethernet switch operates these endpoints through the use of MAC address table, but most of the time we call it CAM table. CAM table stands for content address memory table. Okay, CAM table, also known as the MAC address table. Now here's how it works. In our first example, PCA will attempt to send traffic to PCB. There you go. Okay, but here's the thing. In order for these to be successful, the Ethernet switch needs to learn those endpoints first. Here's how it works. When PCA sends traffic to the Ethernet switch via interface E1, the Ethernet switch will record, it will add the information, layer 2 information of our endpoint, which is PCA. So in our CAM table, what will happen is the MAC address value 01 will be added to Ethernet switch CAM table. 01 because this is the last value here. Okay, and this is learned via interface E1. Why interface E1? Because this is the port that is directly connected from Ethernet switch to PCA. Now, here's the thing. Can it now forward to the destination, which is PCB? The answer is not yet. The reason why is because there's still no value of PCB MAC address in our CAM table. So on the Ethernet switch perspective, I don't know where to send it. I have the source, which is interface E1 with the MAC address of PCA, but I don't know which port should I forward this traffic, this request. This is when what we called broadcast traffic or flooding happens. This is how MAC learning works. So what will happen is the switch, since it doesn't know the destination, where it's connected, it will forward broadcast traffic to all active ports in a broadcast domain. By default, there's only one broadcast domain for Ethernet switch. Okay, consider this Ethernet switch with all of its ports is equivalent to one broadcast domain. So what will happen in this case, it forwards broadcast to Ethernet 2, 3, and 4. And maybe you're thinking, why don't it forwards broadcast to Ethernet 1? Well, it's because that is the source of the traffic. That's where PCA is directly connected. So what will happen is the PCC or server C and server D will receive the broadcast traffic. What will happen is it's not 192.168.1.2. So basically, Ethernet switch will announce who owns 192.168.1.2. Well, on the perspective of server C, well, we're not 1.2, we're not 1.2. When it reach PCB, what will happen is it will respond to the Ethernet switch. It will say, hey, Ethernet switch, I am who you're looking for. My IP address is 192.168.1.2, and this is my MAC address. So Ethernet switch will then add the 02 value in its CAM table, mapping to the interface E2, the port where PCB is directly connected. Now, what will happen the next time PCA initiated traffic to PCB, it will send directly the traffic to PCB without MAC learning, because on the Ethernet switch perspective, I already know where you, PCA, and PCB are connected. If PCA wants to send traffic down to server C, Ethernet switch will then again do the flooding or broadcast traffic.